All right, example 3, we're going to go ahead and find each limit. So these are limits going to infinity. So for the first one, it's our limit as x approaches negative infinity of 2 plus 10 over x squared. So we are going to solve this problem using 2 different methods. Okay, if you recall your law of limits, you can separate this. This is our limit as x approaches negative infinity of 2 plus our limit as x approaches negative infinity of 10 over x squared. And so for the first one, 2 is a constant, and if you remember your limit laws, you would know that if it's a constant, it's going to stay 2. Okay, so my function, this is going to be 2. Graphically, you guys, what's happening is it's a y value, it's a y equals 2 equation, which is a horizontal line, and as it goes to negative infinity, it's going to stay the number 2. Okay. And then I would move on to my second part. It's the limit as x approaches negative infinity of 10 over x squared. Well, this is of the form c over x to the r, which we just got done discussing. If you have a constant over x to some number, the horizontal asymptote, or the limit as you go to positive and negative infinity for this one, is 0. Okay. So this is 0. Or the other way you could think about it is if you think about plugging in a very large negative number for x. So very large negative number squared would make it a very positive very large number. 10 divided by a very, very large number would be 0. Okay, so this would be 2 plus 0, which is 2. That's one way to think about it. Once we kind of get moving through more limit problems, if you guys kind of forget about that you can break it apart that way. So if you do, the first thing you might do is get a common denominator. Okay, so I'm going to rewrite this with a common denominator. So we would have to multiply by x squared. So we'd have 2x squared plus 10 all over x squared. Now this function is not in the form of a constant in the numerator. Since it has that x squared, it's not just a number, it's changing. Okay, so the way you guys tackle it when you have a rational function is you would take what is your largest degree in your denominator and you would divide out by that. Okay, so I would look at my denominator, it is x squared. That's my biggest degree, is the 2. So I would divide everybody out by an x squared. Okay, it's dividing out or factoring out is kind of what we're doing. We're doing a GCF. So I'm going to take out an x squared. So I divide everybody by x squared. Okay, so now I have my limit as x approaches negative infinity. Here's what we did. We took out an x squared. So I put an x squared in the front, and I would reduce each of these. So I have x squared over x squared, which is 2. Plus 10 over x squared. And now here, I took out an x squared, and then I have x squared over x squared, which is 1. Now, when I do this, you could always check to make sure you have the correct simplifying is if you were to redistribute your x squared. Does it go back to what I started with? And it should, and it does, because this would be 2x squared plus 10x squared over x squared, and those would cancel, so you're left with 2x squared plus 10. Okay, so this is the work that we're doing. We're factoring out a GCF of x squared, and it doesn't work out. It's not the typical way you guys think about GCF because there wasn't an x squared with my 10. Okay, but this is how you would write it out. Once you show that, then you guys would notice your x squareds would cancel. So that's nice. So now what I have is my limit as x approaches negative infinity of 2 plus 10 over x squared all over 1. So from here, I now have this part right here, which is a constant over x to the r. And we know that constants over an x or over an x to any power approach 0 as you plug in that infinity. Okay? Which leaves us with 2 plus 0 over 1, which gives me 2. So there is our first example. 2 options to solve it. Both are correct, but I feel like as you guys get going, a lot of you try and make it a fraction, and then this is the route you go. Okay, let's try this again. So a little bit more complicated. We see we're going to infinity, and I have a rational, so I have x's in the top and the bottom. So I'm going to go ahead and divide out by my largest degree in the denominator. So this is an x to the first, and this is an x to the second. So what I got to do is divide everybody by an x squared. So the way we show this work is its limit as x approaches infinity, and I'm factoring out or dividing out an x squared, so I got x squared, and then what does this simplify to when I divide that out? 2. Then I would do the same thing here. I've factored out an x squared, so then I would have x over x squared I'm just going to write that, minus 4x squared over x squared. And then here I'll simplify. We got our limit as x approaches infinity of x squared times 2 all over x squared, and then I would have 1 over x minus 4. Once we do that division, or the taking out of, or factoring out, we're essentially factoring out a GCF. I think it helps to see the division piece of it. The x squareds cancel, so that is nice. And now you guys, when you do this, you are left with something of the form of your constant with your x to an r power. And we know that the limit of that as you go to infinity is 0. So now I have 2, and then I have 1 over x minus 4. So now I'm going to plug in infinity. Okay, if I plug in, once again in quotations, I'm plugging in infinity at 1 over infinity. We know this piece right here will approach 0. Okay, so we are left with 2 over 0 minus 4. So I have 2 over negative 4, which leaves me with negative 1/2. And so there is my limit as you go to infinity. Okay, so you guys, when we're going to infinity and you have a rational, you have to do this. These are the steps you take. Okay, let's go ahead and try another one. We're going to infinity here. So I'm going to go ahead and do the same thing. I look at my denominator. It's a monomial. So I'm going to divide everybody out by an x. So what I have is my limit as x approaches infinity. I'm factoring out an x, so I would have x cubed over x minus 1 over x all over x, and then I had x over x. And then I'm just going to simplify because it kind of got a little crowded here. So we got our limit as x approaches infinity. We would have x squared minus 1 over x all over x times 1. And if you guys aren't sure if you did it right, you can always redistribute what you are factoring out, and it should go back to what we started with. Then from here, my x's would cancel. So I'm left with the limit as x approaches infinity, x squared minus 1 over x all over 1. And now from this point, I can go ahead and plug in infinity. Okay, if I do that, I would have infinity squared. And infinity squared would be infinity minus 1 over my infinity, which we all know is of the form c over x to the r. So that goes to 0 all over 1. So infinity minus 0 is infinity. So this one would actually be an answer of infinity. This part right here, the other thing you guys could do is x squared. You could graph it, and you could say, well, what does that look like as we go to infinity? So as x goes to the right, my y values continue to go up, so that is why that one is infinity. Okay, so there are my limits as we go to infinity examples.